In graph theory, we say that a graph H is an edge-induced subgraph of another graph G if it has a subset of edges from G and includes only the vertices that are endpoints of those edges. So to understand this idea, it helps if we can visualize a graph. So let's consider this graph G right here. This graph has 5 vertices and it has a total of 6 edges. Now, let's say that we have some other graph. Let's call it H. For this graph, we can see it contains 1, 2, 3, 4 of the original vertices from the original graph G, and it also contains 2 of the original edges from graph G. So we would say that the vertex set of graph H is a subset of the vertex set of graph G, and the edge set of graph H is a subset of the edge set of graph G. So we would say that graph H is a subgraph of graph G. But to be considered an edge-induced subgraph, what that means is that for each of the edges that we've chosen to include in this subgraph, so these 2 edges right here, only the vertices that are the endpoints of those edges are allowed to be in this graph. So we can see in graph H, this vertex C right here, it's not an endpoint of either of these 2 chosen edges that we've chosen. So what that means is H is a subgraph of G, but it's not an edge-induced subgraph, because we have this vertex out here that is not connected to either of the edges that we've chosen. So we would say this is not an edge-induced subgraph. But now let's consider another graph I. So this graph I contains 1, 2, 3, 4 of the original vertices from graph G, and we can see that it contains 1, 2, 3, 4 of the original edges from graph G. So because all of the vertices and all of the edges in this graph also exist in graph G, we would say that graph I is a subgraph of graph G. To check if it is an edge-induced subgraph, we just need to check for each of the 4 edges that we've included in this graph, are only the vertices that are the endpoints of those edges included? We would say yes. So only the vertices that are actually touching the edges are included. Or another way of saying that is that there are no isolated vertices. So in graph H, we saw that vertex C, this was an isolated vertex. It wasn't touching any of the edges. So we'll notice in graph I, there are no isolated vertices. So for this one, we would say that yes, I is an edge-induced subgraph of G. And the notation that we would use to describe graph I is we could say it is graph G induced by these 4 edges. So we can write the names of those 4 edges. So here's what that looks like. This is graph G induced by these 4 edges, which are the names of these 4 edges in graph I. So that's the idea behind an edge-induced subgraph.